Hi everyone, welcome back to my class on linear algebra. Okay, so today I'm gonna talk about the continuation of last class. Already we have done around 11 classes on linear algebra. So I hope you might have enjoyed the completely distinct content. Okay, because you will not be able to match these kind of content in particularly if any other gate teacher is teaching you, right? So what I've tried here is I've tried hi Tanisk. I've tried my level best to give you the content which is taught in in Word, you can say, right, the institute like MIT and all. So if you will find question in the gate examination, you would be able to solve it, right? So hi Tanisk, your question is how will approach Selden-Ross probability? See, after linear algebra, I'm going to start probability, right? So in fact, again, I'm going to blow your mind, the way we are going to approach probability, because most of the engineering students, they fall in trap, they watch lectures on various YouTube channels, and they end up not able to solve questions based on probability. So I will be, don't worry about that. The way I have simplified your life in, linear algebra, the similar way I'm gonna simplify your life in probability as well. So in today's session, what I'm going to do here is I will be talking about linear independence of vectors. Okay, I will be talking about linear dependent of vectors. I will also talk about linear span. I will also talk about spanning sets. Then we shall talk about basis and dimensions. So these are the very important concepts, right? What we are supposed to cover today. And these concepts, I believe you guys may not be familiar with. Okay, because since when you go for the interview after cracking gate examination also, you fail to answer the question confidently. So my idea here is to give you a flavor of linearly independent vectors, how we can say, how we can claim that given vectors are linearly independent. So can we switch to the whiteboard? Our favorite board is here, you can see. So I'm gonna make myself a little small so that you guys can watch complete whiteboard. Okay, yeah. So I will request everybody to join, and my voice is I hope my voice might be okay. So this was all about 2 minute previous class as well as Tanis question. Now we will move to the today's topic. So I'm going to talk today about linear independence. Okay, question of linear independence. Okay, linear independence of, you can say, vectors. Okay, so there will be bunch of vectors in the vector space. Okay, hi Pransu, good evening. Yes, so there will be many vectors, right, in the plane, or you can say in the space. It can be two-dimensional space, it can be three-dimensional space, in fact it can be n-dimensional space. Linear algebra is one of the very important topic for machine learning today. If somebody wants to learn machine learning, or yeah, Tanisk. So in fact I'm trying the voice should be good and everything should be good so that you guys can learn better, right? Okay, so linearly independent vectors, today I'm going to talk. So what is the meaning of linearly independent vectors? So I'm not going to give you any bookies definition in first go. I'm just going to take some of the vectors and I'm going to show you how we can say, yeah, these vectors are linearly independent vectors. Okay, so or if they fail to be linearly independent, then we can say that they will be linearly dependent. Okay, but at the end of the day, I'm gonna tell you the systematic approach. Okay, that for what I'm known for, right? So let me take a couple of vectors here. Suppose we have got the vector x. Okay, you take just vector x, and I'm going to take two component only, two-dimensional vector, you can say, that is 1 and 2, right? And this is just a column vector, right? Everybody, I hope, might be understanding that from where we are getting these vectors. We are getting these vectors, from the system of linear equation only, right? Okay, and next vector we have taken here is 3 and 6 you take. Okay, so we have got two vectors. One vector is x, one vector is y. Okay, and we can take again two vectors. One vector is x again. Suppose this is one vector like 1 and 2, and this y is, the y vector is given as 1 and -1. So we have got couple of component in one vector, right? And we know that we can find the norms of a vector. We can do, we can add two vectors, we can multiply by scalar constant with any vectors. Okay, so depending upon our need, we can do all these things, right? So keep this in mind. These are the simple operations that you can always perform, okay, whenever you are given a vector. Or suppose I have given you some number, right? 2 3 4 5 6 7 8, like that. So what are the things you can do with the numbers, right? You can always add numbers, you can multiply numbers, you can divide numbers, okay? Or but don't forget that never divide by 0, right? And you can do many things, right? The way here also we are going to do. So we have got x and y, and we have again got x and y. These are the two sets of vectors we have taken. Now you see, guys, you see x is basically 1 and 2, right? But if you give your closer observation to y, you can take something out from here. The scalar constant you can take out. So the vector is same, x and y, these two vectors are same. Yes, I'm talking about linear independence, I'm not talking about span right now. So x and y, you see here, both vectors are same, provided, okay, provided y is what? Y is 3 times of the you can say the vector x, okay, 2 times means scalar multiplication. If you multiply by scalar to x, okay, so what will happen? Your y will become 3 and 6, okay, like your x will become 3 and 6, remember, right? So what is there? You are able to write x is equal to 3y, okay, x is equal to lambda times something, so you are able to write x is equal to lambda times y, okay, and this lambda is not constant. I mean, this lambda is not zero, this lambda is non-zero value, okay. If this lambda is non-zero value, means you are able to express, I think this is okay, we have written something wrong here, so we can correct, okay. So this is basically lambda, okay, y equal to 3 times, that we have to take, y is equal to 3 times x, that you have to understand, okay, because y is 3 times of x, okay. So you are able to express y in terms of x, okay. If you are able to express y in terms of x, then what comment you can do? You can say that they are not linearly independent, okay, they are linearly dependent, okay, they are linearly dependent. So if one vector is there, and you are able to express that vector in terms of another vector by multiplying some scalar constant, okay, it can be real constant, it can be imaginary, so that you have to keep in mind. So they are LD, okay, linearly dependent vector. Keep this in mind, okay. I will give you the formal definition as well, but for the moment, as I have taken some examples, you have to understand. Now you see here, x and y, okay, these two vectors are completely different. You can't express one vector in terms of another vector. Yes, Tanis, Pransu, and other people who are watching us, right? So whoever will be joining the session, please hit the like button as well, so that I will be understanding, yeah, this many students are watching us, right? Because there are only 15 to 16 students in my class, right? Okay. So you see here, these two vectors cannot be written, cannot be expressed in terms of one another. You can say that they are Li vectors, right? Linearly independent vectors, okay. So if you're able to write, remember, if you're able to write, suppose you are writing lambda 1 times x plus lambda 2 times y, which is equal to 0, okay, which is equal to 0. So remember, when this is possible, can somebody tell me when lambda 1 times, yes, yeah, Tanis, great. So when lambda 1 times x plus lambda 2 times y will be equal to 0, can somebody comment on here? Because x is non-zero, y is non-zero. When it is possible, okay, when it is possible, can someone tell me when it is possible? So what I'm trying to say here is I'm multiplying by scalar constant lambda 1 with the lambda x, okay, with x, and then we are taking the linear combination of them, okay. We are taking the linear combination of two vectors, okay. So this should be equal to 0 if and only if. IFF means what? If and only if, okay. When it is possible, when linear combination is gonna be 0. Can somebody tell me here when it is possible? As we know that these two vectors are non-zero, when scalar constant will be 0, right? You have to make sure that, okay, where lambda1 and lambda2 should be equal to 0. Okay, this is very important statement, okay, for Li vectors. Okay, for Li vectors, this is very important statement, right? This is very important. Why I'm saying that lambda1 and lambda2 should be equal to 0, you can check here. Suppose we want to express lambda1x plus lambda2y equal to 0, so it becomes lambda1x equal to minus lambda2y. Okay, and then you can write x is equal to what? Minus lambda2 by lambda1, and this is what? This is by. Okay, so if you want to express like this, okay, so lambda1, here there is some restriction, you know, lambda1 cannot be taken as 0 in this case right here, but until lambda1 equal to 0, lambda2 equal to 0, okay, this cannot become 0, right? So for Li vectors, these two constants should be equal to 0. So you can say that x cannot be expressed in terms of by, okay, because there is a restriction. Okay, there is a restriction. Understood? So please keep this in mind. Okay, if one vector is you are not able to express in terms of another vector, so they are Li vectors, right? But I will give you systematic approach, okay, because you know we have been given a two-dimensional vector where two components are present, so we are able to see directly, you know, by with our naked eyes, you know, we are able to answer the question. But when three-dimensional picture will be given, or you know n-dimensional picture will be given, then you will not be able to comment. Okay, let's move ahead. So what is the definition? What is that definition, right? So the formal definition for linearly independent vector is, okay, formal definition, right, of Li is going to be, keep this in mind. Okay, so I'm going to take one vector space. Okay, so let V be a vector space. Okay, vector space. In fact, I'm gonna explain. I will be taking one separate session to explain what is the meaning of vector space, right? But keep in mind, vector space means there will be bunch of vectors. Okay, just like a plane, you can say. Okay, thin sheet, and there are many vectors lying on that plane. Okay, it can be two-dimensional, it can be three-dimensional, it can be n-dimensional. Okay, so let B be a vector space. Okay, and a finite set of vectors are there. Okay, so you can say there are finite set of vectors. Finite set of vectors are there. Okay, like v1, v2, and v3, and so on, vn. Okay, and they are said to be linearly independent if and only if. Remember, if, or you can say if only if you write linear combination of them. What is the linear combination of them? Lambda1 v1 plus lambda2 v2 plus and so on plus lambda and vn. Okay, if you write linear combination of them, they should be equal to 0. Okay, they should be equal to 0. What is the meaning of that? When it is possible, if and only if lambda1 equal to lambda2 equal to lambda3 equal to and so on and so forth, lambda n should be equal to 0. Okay, so these scalar constant, if they are coming out to be 0, then you can say linearly independent vectors. Okay, if any one of the, you know, if any one of the scalar constants are not 0, then they are linearly dependent, right? So this is the definition which is given in the book. I hope this makes sense. Everybody understood this? Now I will give you systematic approach. Okay, so, and this is very important. So I think you need systematic approach because you might be hungry for systematic approach, right? So I'm just going to give you systematic approach. Okay, systematic. Okay, so this is my approach, you can say, hashtag Dheeraj sir approach. Okay, so the very first thing will be what? The very first thing, keep this in mind, the very first step is there will be many vectors. You can say they will be the column vectors and number of column vectors. You can say like v1, v2, and so on, vn column vectors, right? There are v and column vectors. Okay, then what you can do, you can construct a matrix now. Okay, you need to construct a matrix. How to construct a matrix, guys? How to construct a matrix? I think everybody knows. Just put column. Okay, that's it. Okay, all together it forms a matrix, nothing else. So I'm just going to write here, construct a matrix, construct the matrix. Okay, the matrix you can say is R matrix you are constructing, and just write them like v1, v2 and so on, all the column vectors, okay, to form a matrix. Next what you have to do here is, then you have to find the number of pivots variable. Okay, then the next step is find the number of pivots variable. How can you find the number of pivots variable, guys? You can find the number of pivots variable by applying elimination, right? If you will reduce it to echelon form, then you can find the number of pivot variable. See, finding the pivot variable, it means that finding the rank of the matrix. Okay, finding the rank of the matrix. Okay, whatever matrix you have formed, you can directly tell, yeah, if number of pivots are 3, the rank of the matrix is gonna be 3. Okay, I have told you this approach because I know you guys are familiar with only how to find the matrix, how to find the rank of the matrix, just by finding the determinant of the matrix, right? If determinant is coming out to be 0, so rank of the matrix will be less than the order of the matrix. Yeah, this concept everybody knows. I mean, rank of the matrix in terms of determinant of the matrix, right? That you know. But I have told you, if you count the number of pivots in the column, okay, after reducing it to echelon form, after applying elimination, the powerful tool in entire linear algebra, okay, this word is very important, elimination. Okay, so this is simple matrix. Okay, simple matrix you take and find the number of pivots, find the number of pivots. Okay, find the number of pivots variable. Okay, or you can say rank of the matrix, rank of matrix. Okay, so if you have done these 3 steps you have to perform. I think this is very simple, and since we have been taking linear algebra session, all the time I repeat these 3 steps, right? Okay, so if you have done this, then the case will come into picture. Okay, then the case will come into picture. Okay, what, there will be 2 cases. There will be 2 cases. Suppose the matrix is a square matrix. Okay, if the matrix is a square matrix, okay, so what will happen here is that the number of pivots, okay, number of pivots will be equal to number of it can be, you can say that number of pivots are equal to number of unknowns, right? Or you can say number of unknown, or number of order of the matrix, you can say, right? Or rank of the matrix. Okay, so if it is less than, okay, if the rank of the matrix is less than the order of the matrix, okay, then what will happen? Then what will happen, guys? You can say that these vectors are not linearly independent. Okay, so this is the test you have to do, right? The systematic approach of investigating Li and Ld is this. Okay, this is very good approach. Okay, what is the meaning of this? What is the meaning of this? What I'm trying to say here is that if, remember, if number of pivots, right, number of pivots or rank of matrix, okay, rank of matrix, which matrix? R, okay, is less than, or you can say is equal to n. N is what? Number of unknown, right? Here it can be number of pivots or rank of matrix, okay, n. Sorry, rank of the matrix is less than n, right? So in this case, if this happens to be okay there, so vectors will be Li vectors, okay, and if this happens, then you can say that vectors will be Ld. Okay, understood? If number of pivots are what? If number of pivots are coming out to be less than, okay, less than the number of unknown. Let me write again. If number of pivots is equal to number of unknown, okay, then given vectors, you can say set of vectors, set of vectors will be Li1. Okay, I hope this makes sense. If number of, this hashtag means number of, you can say. Okay, keep this in mind, number of pivots is less than number of unknown. Okay, then LD. Okay, LD. So this is the systematic approach of finding. Okay, and one more way, suppose the matrix is square matrix. Okay, and if you're trying to find the determinant of the matrix, right, and if the determinant of the matrix is what, determinant of the matrix is 0. Okay, so it becomes a singular matrix. Okay, what is the meaning of determinant? Yes, Francois is asking how it is so. This is the systematic approach. Okay, so this approach you have to follow always, right? So if you are able to do like this, means you cannot express them as a you can't express one vector in terms of another vector, right? See, why I'm saying like this, because suppose two rows are what, two rows are depending to each other, right? Then what will happen, the matrix, you know, the determinant is certainly going to be what, 0. In fact, if it is a square matrix, right, and if it is not a square matrix, then what will happen, the rank of the matrix will be less than the unknown. Okay, understood? If rank of the matrix is less than the number of unknown, it means there are vectors. Okay, it can be column vectors, it can be row vectors, they are depending to each other. How they dependent on each other, you know, how they are dependent on each other, they might be proportional to each other. Okay, I hope this makes sense, Pransu. Yes, देखो, you take three columns, first column, second column, third column, right? If you are able to express one column in terms of another column, right, what will happen, the rank of the matrix, or you can say the number of pivots, okay, while applying elimination, while reducing to echelon form, what will happen, remember, this is very important. Okay, and I'm very glad that this kind of a thought process you guys have got now, right? So I know if I will give you matrix, you will be able to tell directly, but you know, the hidden concept you should understand always. Yes, yeah. See, if rank reduces, you know, or you can say linearly, if the given vectors are linearly dependent, so what will happen, the rank of the matrix will be always less than the number of unknown. Okay, and what is the meaning of number of unknown? Number of unknown means the number of column, okay, present in the matrix, that you have to understand, right? Perfect. So this is one way of investigating, and one more way of investigating is, suppose you have formed the matrix. Okay, you have got the matrix after putting column. Okay, and that matrix is coming out to be square matrix. Okay, if the matrix is given, okay, that matrix you have got, in the exam, what will happen, they will give you the vectors and they will ask whether they are linearly independent or dependent. So what you will say, sir, first of all I will form a matrix, right? You form a matrix, you put, perfect, then if by observation you will be able to understand, yeah, it is a square matrix, I mean number of rows will be equal to number of columns. Okay, so then you don't have to do any you don't have to write echelon form at all. What you can do, you can always go for, you can find the determinant. Okay, but I would suggest guys, apply always elimination and reduce it to row echelon form, because sometimes what will happen, if you are finding the determinant of the matrix, right, it might happen that it can be 0 if the matrix is singular matrix, right? If the matrix is singular matrix, right, so it will be 0. Okay, if the rank of the matrix, sorry, if the determinant of the matrix is 0, then what you can say, that always then the rank of A will be less than always the unknown, right? And if it is not coming out to be 0, so rank of A will be equal to n, right? I'm trying to say here is the rank, or you can say number of pivots. Okay, it depends upon you how you are going to consume. Okay, because after all I will be dedicating one session on rank as well, and I will tell you around 5 definitions of rank. Okay, so in this case when the determinant is not equal to 0, it means it is a non-singular matrix. What we call it? Non-singular matrix. Okay, if the matrix is non-singular matrix, then determinant is not going to be 0. If the matrix is singular matrix, then you can say that the matrix is singular. I mean, the determinant is going to be 0, right? So in this case, the vectors are LD. In this case, the vector will be LI. That's it. I hope this makes sense. So in the examination, they will not directly give you the matrix, and they will ask, please solve me, right? They will not ask, right? They will give you the set of vectors in certain vector space, okay? And that vector space where you can always play, you can hit the 6, okay? There will no problem at all, guys, right? Never people will not come and say that, oh, your son has hit the 6 and it has broken my window. No, you consider a kind of vector space where you can play, you can do anything, guys, okay? Like you can add two vectors, you multiply, that vector should stay in the same space only. Like if you hit the 6, that ball should be always inside it, right? Okay, it should not hit somebody's if that will cross, right, the playground. Okay, so that is what the vector space you can always imagine. तो ये याद रखना हमेशा, ठीक है? सबको समझ आया क्या? शुभम and Tanis, Pransu, there are many people, yeah. So I hope everybody might be enjoying here, and okay. And one more concept I'm gonna give you. See, when you can say that there is a LD vector, I mean these vectors are LD, linearly dependent vectors. See, if the matrix is what? Square matrix, you can always find the determinant and you can check. But suppose the matrix is not an square matrix, then you apply the elimination, you reduce it to row echelon form and see whether there will be free variables. Okay, if there are free variables, then vectors are not linearly independent, right? So remember, this is very important concept. Okay, okay, if there are free variables, then set of vectors, I think everybody knows what is free variable. Okay, set of vectors are what? LD, linearly dependent vectors. Okay, this is one way. Okay, so how can you yeah, this is very important concept. Yes, the free variable is nothing but, I think you might have heard about nullity. In one of the session, I have also explained what is free variable, right? Where pivots will not exist. See, suppose one column has a pivot, second column has a pivot, third column does not have a pivot, means that variable will be considered as a free variable. Okay, where the pivots are not there. I mean that pivot, suppose that last one is 0, last element, right? So you can't take that element as a pivot. I believe this is fine. Yeah, so these are the concepts which you have to remember, okay, for linearly independent vectors. So one question was there in GATE 2015, right? Let me tell here itself, in GATE 2015, okay, in chemical engineering. Okay, so they have given a following set of 3 vectors, right? So they have given here the following set of 3 vectors. Okay, yeah, so what are these vectors they have mentioned? One vector is 1 2 1, second vector they have mentioned is x 6 and x, and third vector they have mentioned is 3 4 2, right? And they are saying that is linearly independent. They are what? They are linearly dependent, not independent, sorry, dependent, right? When x is equal to, okay, so how can you solve this question? Okay, yes, see, they have given in the GATE exam following set of 3 vectors, okay, and they are saying that these are linearly dependent vectors, okay, when x will be equal to, okay, So x value you have to find here. So x value. So option A, option B, option C, option D. They have mentioned some values, right? 0, 1, 2, and 3. So you have to find the value of x. So yeah, determinant should be equal to 0. Or what you can do here is, or you apply the elimination, okay, and see, okay, see whether there will be a free variable or not, right? If free variable will be there, means that something, some equation you will get, okay, that some algebraic expression you will get, x minus 3, that you can always equate to 0, because you don't want pivot over there, right? Yes, Subham and Pransu. Yes, Subham. Yes, Pransu, your answer is correct. 3. The answer will be 3. Right? It is very easy question. Okay. Everybody understood this? So you can go for, you can find the determinant of the matrix, or you can also apply the elimination. I'm not going to tell you anything now here, because I have given you the concept. You know how to apply elimination, okay? And don't take me wrong, guys, okay? All the time I'm not gonna, repeat the same thing like elimination, applying, yeah, okay? Okay. Because I believe the second and third are dependent if x is a subset. Uh, yes, see, but the thing is, by observation, not everything does not work, right? So yeah, if you're able to see like that, yes, okay, but try to go for systematic approach, because in the gate examination you are given a time. I think it does not take more than 40 seconds to answer. Yeah, yes, because see, because there are 3 vectors, 2 vectors are there, it's okay, but 3 vectors are there. So conclusion, and they already said that dependent, they are linearly dependent. Yes, so here we don't have to investigate whether they are linearly dependent, we have to directly find the value of x. So better to transfer first and second column will be by observation. Yes, so this is very important to understand. Okay guys, let's move ahead. That you can do always, okay, by inspection you can always solve. I don't have any problem, right? So yes, if you pick up the value here, okay, x value 2, okay, and so what will happen then? Certainly any constant if you take here, like if you multiply by that, okay, so keep this in mind. By inspection it is good, and if you know everything, right? Perfect. So moving forward, if I give you again set of vectors, I think you will be able to do. So I'm not going to give you anything now. And if there are 4 vectors, right, so if there are 4 vectors, always keep this in mind, guys. Let me tell you, suppose we have got 4 vectors, okay, given 4 vectors, okay, so 1 minus 1 1, these are the column vectors, okay, 4 1 2, and they have given 2 minus 3 and 3, 2 1 0, okay? They have given 4 vectors, right? Now what you have to do here is, can somebody tell me how many equations will be there? How many equations will be there, and how many unknowns are there? Yes, how many unknowns are there? Anybody? First of all, we need to understand how many unknowns will be there. There will be 4 unknowns. Why? Because there are 4 columns, right? So if you form a matrix, it will be 3 by 4 matrix, okay, and there are 3 equations, okay, there are 3 equations. So number of equations are less than number of unknowns. Number of unknowns are always greater here, right? And I think you should be able to now conclude one point here, right? Okay, so what you can do here is always you can take, yeah, 3 unknowns. No, not 3 unknowns, there will be 4 unknowns, okay, Subham, because no, not 3, okay, there will be 4 unknowns. So there are 4 columns. Please go back and check the lectures which I have told you, right? ठीक है, तो यहाँ पर ऐसा बोल सकते हो, number of equations is less than number of unknowns. Okay, so I think you should be able to tell now. Yes. So what is your take on then? Whether they are linearly dependent or linearly independent? Yes, they will be linearly dependent, right? Directly you can say, right? Because if you try to find the number of pivot variables, so how many pivot variable is possible here in this case? Only three. Only three pivots are possible. Always keep in mind whenever imbalance equation is given. Okay, like you know, four vectors are there, right? Four vectors are there, but what is the dimension of this? You see, three components are there. Okay, so four vectors in R3. Yes, three dimensional. So which statement? This statement you're talking about? Yes, there is a proof. You can try now. You can check. I have told you also in the beginning. Okay, this denotes that if this kind of a situation happens to be, right, so there can be solution, there cannot be solution. If there can be solution means there will not be unique solution, right? There will be always what? The infinitely many solutions. And if there will be infinitely many solutions means what? There will be free variables, right? There will be free variables. अब अगर इस केस में, in this case, what kind of situation might occur? See, you will never get unique solution in this case. Okay, what kind of solution you will get? You will get infinitely many solutions or no solution also. Suppose you get infinitely many solutions, right? You will get some infinitely many solutions. Then there will be free variables, right? If there, what I have told you, if there is a free variable, means these four vectors are linearly dependent. Okay, they are linearly dependent vectors. You don't have to do anything then. I hope this makes sense. Okay, so please go back and check all the lectures, because all lectures are interrelated to each other. Okay, and the way I speak is always some sentence I always prefer to bring in all the press sessions, right? So that you guys can uh, remember for all the time, right? समझ आया क्या? How I'm claiming that these four vectors are linearly dependent? See, there are three components, okay, and there are four vectors, and we are by inspection we are saying that Pransu is saying, sir, समझ नहीं आया ये वाला. अच्छा, Pransu, have you watched the previous sessions? देखो, previous session if you have watched, right, when you can get unique solution, tell me here. See, or say, apply the systematic approach. If you don't want to understand the way I'm saying right now, relating with the previous concept, with the concept like when we will get unique solution or when we will get infinitely many solutions. So what you can do, you just write all these vectors, okay, column vectors in the one matrix, right, and then apply elimination and then see whether free variable will exist or not. Certainly there will be free variable. Let me tell you. देखो, अगर मान लो this kind of situation is there, 1 2 3 4 5 6 7 8 9 10 11 12, right? This kind of situation. Suppose I'm just taking one example here, right? Don't take it like a valid question. ठीक है, अब यार देखो ये तो फिर मेरी मिस्टेक नहीं है ना. Okay, these lectures are public as well, right? So 1 2 3 4 5 6. हाँ, यस, शुभम को याद है पूरा, ठीक है, क्योंकि शुभम हैज ऑलरेडी फेस चैलेंज एट आईआईटी कानपुर, राइट? सो देखो, एक बार चैलेंज फेस करोगे ना तभी समझ जाएगा, भूलेगा कभी नहीं, ठीक है. इन माय केस आल्सो व्हेनेवर आई फेस चैलेंज, दोस थिंग्स ऑलवेज किक्स इन माय माइंड, कभी भूल नहीं सकता. लेकिन जब यार कहते हैं ना, जैसे एक बार क्या होता था कि इन द गेट एग्जाम व्हेन ब्लॉक डायग्राम क्वेश्चन यूज्ड टू बी आस्क्ड, हर बार मेरा गलत होता था, हर बार, ठीक है, ब्लॉक डायग्राम का क्वेश्चन. अब नहीं गलत होता. क्यों? क्योंकि ब्लॉक डायग्राम, क्यों? क्योंकि मैं उसको लाइटली लेता था. ओ, दिस क्वेश्चन इज वेरी बेसिक यार, एनीवन कैन डू, बट इफ यू वांट टू गेट रैंक you have to get complete marks, right? You have to solve everything. Okay, so suppose this kind of situation. So how many pivots variable is possible here? This is 3 by 4 matrix. Tell me guys, how many pivot variable is possible in this case? कितने pivots हम ला सकते हैं इसमें, बताओ. पॉसिबिलिटी कितनी है बताओ। शुभम, कैन यू टेल मी हाउ मेनी पिवट्स वी कैन हैव हियर, एंड प्रांशु आल्सो। See, there can be maximum 3 pivots, right? Let me highlight this point. This can be one pivot, this can be one pivot, this can be one pivot, okay? While applying the elimination. ठीक है, हाँ। तो देखो यहाँ पर क्या है, जब नंबर ऑफ पिवट्स कितने हैं, 3 है, राइट? मतलब रैंक ऑटोमेटिक्स पॉसिबल कितनी है, 3। रैंक 3 हो सकती है, मैक्सिमम रैंक 3 हो सकती है, राइट? और रैंक क्या है, लेस है नंबर ऑफ अननोन से, राइट? ओके, इट शुड बी इक्वल। लीनियरली इंडिपेंडेंट के लिए क्या इक्वल होना चाहिए, इक्वल नहीं है यहाँ पर। इफ इट इज नॉट इक्वल देन व्हाट विल हैपन, you can say that they are linearly independent, they are linearly dependent, right? तो ये these kind of a situation you have to keep in mind, right? क्योंकि इससे जनरलाइज वे में कोई नहीं बताने वाला, ठीक है? बहुत ज्यादा कंफ्यूजन रहेगा आपको अगर आप दिन भर रैंक बस सोचोगे कि अच्छा डिटर्मिनेंट, यार 4x4 का मैट्रिक्स है, सॉरी 3x4 का मैट्रिक्स है, ठीक है? इफ यू गो फॉर सब मैट्रिक्स एंड फाइंड द डिटर्मिनेंट, ओके, टेक सम स्क्वायर मैट्रिक्स, फाइंड द डिटर्मिनेंट, टेक सम स्क्वायर मैट्रिक्स, फाइंड द डिटर्मिनेंट, कितना टाइम लगेगा? सबको वही कॉन्सेप्ट पता है, ठीक है? एवरीबॉडी नोज द सेम कॉन्सेप्ट। व्हाट, आप कोई भी यूट्यूब चैनल रेफर कर लो इंडिया का, मतलब जितने भी गेट की बात मैं कर रहा हूँ, राइट? आई एम नॉट टॉक अबाउट MIT और NPTEL और some other content. I'm talking about these content like people are, so you see there they will pick up always sub matrix and they will force you to find determinant. अब आप लोग फाइंड करोगे डिटर्मिनेंट, कितने डिटर्मिनेंट फाइंड करने वाले हो, कितना करोगे, कब तक करोगे, राइट? तो उससे में तो टाइम तो निकल गया ना। तो बेटर टू फॉलो सिस्टमैटिक अप्रोच। समझ आया क्या? यस गाइस, टेल मी फास्ट सो दैट वी कैन प्रोसीड अहेड, ठीक है? Okay, so let's move ahead and we'll go ahead and talk about okay, so we have lost the time, okay? I wanted to teach today everything like linear spanning sets and basis dimension and all, but for the moment I have just covered partial information about basis, ठीक है? क्योंकि for basis to understand there should be linearly independent vectors, ठीक है? जो बेसिस होने आने वाला है ना, कॉन्सेप्ट ऑफ बेसिस, राइट? उस कॉन्सेप्ट ऑफ बेसिस में रिमेंबर ऑलवेज व्हाट काइंड ऑफ वेक्टर विल बी देयर इन द बेसिस, और यू कैन से इन द सेट linearly independent vectors will be there. Linearly independent vectors. अब आप लोगों को लग रहा होगा सर ये टॉपिक है, टॉपिक नहीं है। देखो, if you want to understand basis you need to know the what, you need to know linearly independent concept, ठीक है? कॉन्सेप्ट है ये। इफ यू वांट टू अंडरस्टैंड फ्यूचर कॉन्सेप्ट तो ये कॉन्सेप्ट आपको याद होना चाहिए। मैं कल बोला भी था, इफ यू वांट टू अंडरस्टैंड बाइपोलर जंक्शन ट्रांजिस्टर तो यू शुड अंडरस्टैंड द पी एन जंक्शन, राइट? द बिल्डिंग ब्लॉक, ओके? तो आप क्या करने वाले हैं, नेक्स्ट क्लास में हम लोग कंडक्ट करेंगे, क्योंकि लर्न वन बाय वन, ओके? बिकम हंग्री, ओके? ठीक है, चलो, विल मीट इन द नेक्स्ट सेशन गाइस एंड विल डिस्कस linear span. Okay, it is not new. Then spanning set. Then we will talk about basis and dimension. Then also we'll talk about rank of matrix. Okay, in terms of determinant, and there will be 5 definitions, okay? 5 definition I will give you for the rank. One definition already I have given you, number of pivot column, okay? जितने pivots होंगे each column में वही तुम्हारा rank होगा, ठीक है? जैसे मैंने बताया अभी, what I have told you guys, see 1 2 3 pivots are there, so we call it 3 rank is 3. अब यार don't waste your time guys, okay, finding determinant and all, right? चलो ठीक है, we'll meet in the next session. I hope you might have enjoyed the session. So So these sessions are not public. Sometimes I share these sessions, for students to know these concepts, but these sessions are only being conducted for only 15 students who are in my group, right? So they have to take it very serious, okay, whenever I give any concept, right? Okay, and learn better and let me know always, okay? You have to keep giving me the feedback so that I can improvise more concept, right, and bring for you. Thank you. So we will meet again, guys. Okay. So because one concept, makes us insane. ठीक है, कोई भी एक concept हम लोग सीखते हैं तो we become insane about it, right? We start loving this concept, right? We can never forget. Okay, so please keep this in mind. ठीक है, चलो ठीक है, we'll meet in the next session. Bye bye and take care. Thank you.